Okay, so good evening, class. Today we are going to learn about the origin of the Earth and the solar system. So under that, origin of the Earth and solar system, we know that the planets originate in a dense disk formed from material in the gas and dust cloud that collapses to give us the sun. The density of this disk had to be sufficient to allow the formation of the planets and yet to be thin enough for residual matter to be blown away by the sun as its energy output increases. Okay, so the main theories are the passing star theory. The theory was advanced by Jeans and Jeffries, and the theory states that the sun existed earlier than the planets. A big star with greater gravitational force than the sun passed nearby and attracted large quantities of material in form of gases from the sun. The material split into portions as they cooled and condensed to form planets. They were then set into orbits around the sun. The smaller materials formed the heavenly bodies like the moon and asteroids. As cooling continued, heavier materials cooled at the center and formed the core of the Earth. The less dense materials collected around the core to form the mantle, then crust. Another theory we have is the nebula cloud hypothesis. So the hypothesis suggested that the solar system started out as a nebula cloud, which is a large rotating cloud of dust and gases. Due to acceleration in its rotation, nebula thus flattening into a disk oriented perpendicularly to its axis of rotation. The planets and sun were concentrated from the dust and gases in the cloud by gravitational. So the summary of other theories on Earth's origin, the planets were spun off the sun. So this theory suggests that the planets were spun off the sun and thus are essentially daughters of the sun. We have their weaknesses. If this were the way that the solar system formed, then the sun would have most of the angular momentum and the sun will be less massive. It is the Big Bang theory. It presupposes the existence of a universe initiating explosion. Light elements were formed during the early stages of the Big Bang, creating a universe composed principally of hydrogen and helium. So we have characteristics of the solar system. It is part of a nebula. Most of the masses of the solar system is concentrated in the sun. The planets and the sun each have a somewhat different density, suggesting different times and temperatures of origin. Heavy noble gases are rare on Earth as compared to space and the sun. 98% of the angular momentum is found in the planets. So we have the Earth's thermal structure. The interior of the Earth is very hot because of three heat sources. One, the heat of formation. The original heat is still retained long after material broke away from the sun. The weight of millions of tons of the crucial rocks that cover the interior, thus generating pressure-caused heat. And lastly, radioactive heat. There is constant explosion of radioactive materials within the interior of the Earth due to nuclear fusion, thus generating heat. Okay, so we also have the shape of the Earth. The shape of the Earth is described as spherical, though not a perfect sphere. It is slightly wider at the equator and flattened at the poles, giving it a shape called a geoid or oblate.